Today we're going to work with complex numbers and imaginary numbers. As you've seen before, we were able to, in the past, look at square roots that were negative and say, hey, we can't take the square root of a negative. So that's going to be in the past. Now we're going to move forward with imaginary numbers, and we're going to find a way to go ahead and find the solution when we have a negative in my radicand, and it's going to give us something else besides no real solution. So basically what it's saying here is that if we have the square root of a negative, we're going to call that an imaginary number I. And so we're going to use I to solve complex numbers, or take the root of a negative number. And we're going to see how this works. So for this, we're going to work strictly with I to the power of 2 equals a negative 1. So what we're going to do here is we're going to derive something new. So what we do here is, if we take the square root of both sides, okay, remember that when you take the square root of something that has a power of 2, that those operations undo each other. And so what you get left with I equals the square root of a negative 1. And so we're going to use this. So again, we can go back and forth between this expression here, between this right here, and to okay. You can go back and forth. Again, how do we do this? Well, how can we go from here to here? All we can do is say, guess what? Take the square root of that, take the square root of that, and guess what? This turns into that. Because again, the power of 2 undoes the radical. So again, we're going to use that as a reminder that whenever we see negative radicals, or I squared always equals negative 1. Okay? So make sure we write this down, or take a mental note of this. So the same way we did before is, we know that we can, how do you get negative 5? You say negative 1 times 5. We can break it up into the square root of negative 1 times square root of 5. And once you get there, you can say, hey, guess what? We have the square root of a negative number. What does that equal? Well, this equals I. Okay? This equals I. And we have the square root of 5 as my answer. Okay? So all we're really doing, again, is we're taking out a negative 1, right, as a factor. Once we get to negative 1, we separate the radicals. Once we separate the radicals, we say, hey, guess what? We have a square root of negative 1. A square root of negative 1 is I. Okay? So you can see here, we're doing the same thing as the first example. The fifth example down here, or actually the third example, knowing that when you have a large value, sometimes you have to say, hey, guess what? There is a perfect square hidden in a large value, and I gotta see if I can find it. So now we're going to deal with complex numbers. And complex numbers means you have a component that's going to be a real number, and you have a component that's going to be an imaginary component. When you multiply complex numbers, the idea is, in this case, when we add complex numbers, is that you add the real portions together, and then you add or subtract the imaginary parts together. So again, we're going to see how this works. So for the first one, they're both imaginary components, so we go ahead and add those together. The second part over here is we have two binomials, and these binomials, look, they have a real part and then an imaginary part. So what we're going to do is we're going to go ahead and add the real parts together and add the imaginary parts together. Okay, and so again, be careful when there's no negative sign here, or when there's a negative sign, we have to distribute here, we don't. So we take -5 and 2, and so we get left with -3. We have +6i and -11i, and so with that we get -5i, and so that's going to be our answer there. And again, adding the real parts to the real parts and the imaginary parts to the imaginary parts. So same thing over here, but now we have a negative, and then whenever you have a negative in front of parentheses, just remember that we always have to distribute. So we distribute there and there, and so what that gives us is going to give us a positive, sorry, -4. It's going to change it into a minus, and then -4. So when we go ahead and add, it's no longer +4, right? The 2 and the 4. It's no longer positive, so it's going to be -4. So we're going to get a -2. 3i. Again, it used to be a +2i. Now it's going to be a -2i. So we have 3i minus 2i is going to be a positive i. And there we go. And that's adding or subtracting complex numbers. The tricky part is just if there's a negative symbol, we have to distribute. Multiplying and dividing complex numbers. So this is where we're going to go ahead and bring back the concept of I squared equals -1. Okay? I squared equals -1. So we're going to say that when you multiply 3 and 4i, you're going to get 12i squared, because you multiply I times I is I squared. And again, what does I squared equal? I squared equals -1. So the answer becomes 12 times -1, which is going to be -12. Right here, kind of the same thing. We're going to square the I, square the 7. So we have 49i squared. And then you get 49 Again, what's I squared? I squared is going to be negative 1. Okay? And so you get left with negative 49. And that's multiplying complex numbers. So now we're going to go ahead and do foiling. And with foiling, again, we're going to multiply the 2 and the 3. That's going to give us 6. The 2 and the 10i is going to give us a plus 20i. We're going to multiply the negative I to the 3. It's going to give minus 3i. And then the negative I to the 10i is going to give us a negative 10i squared. And once again, we combine all like terms. And we're going to be left with 6 plus 17i minus 10 and negative 1 because I squared. It's going to be positive. So we're going to get left with 6 plus 17i plus 10. We add the 10 and the 6. We're going to get 16 plus 17i. Now, as standard form, or if you want to call it standard form, you always want to have your answer with the constant first and then your I last. So again, in your answers, always have the complex number at the end. This is helpful.